Our lesson today is to be able to solve a system of linear inequalities. Uh, a system of linear inequalities is a set of two or more linear inequalities in the same variables. An example is shown below. We have y is less than a number x plus 2, and we have y is greater than or equal to 2 times a number x minus 1. A solution of a system of linear inequalities in two variables is an ordered pair. That is a solution of each inequality in the system. So let's put this down here. So our first example, we want to be able to check to see if an ordered pair is a solution of a given system of inequalities. So for example A, we want to replace x with 3. We want to replace y with 5. And see in both inequalities and see if we get two statements. So for the first inequality, we're going to have 5 is going to be less than 2 times 3. Is 5 less than 6? Right? That's a yes. And then we have 5 is greater than or equal to 3 plus 1. Is 5 greater than or equal to 4? Right? The answer is yes. So that means this ordered pair is a solution to that system of inequalities, because we have a yes for the first inequality, we have a yes for the second inequality. All right, let's check the second example. We're going to replace x with negative 2, we're going to replace y with 0, and see what kind of statements we get. Is 0 less than 2 times negative 2? Is 0 less than negative 4? The answer to that is no. Alright, so let's check the next one. We have 0 is greater than or equal to negative 2 plus 1. Is 0 greater than or equal to negative 1? Right, the answer to that is yes. But a solution to a system of linear inequalities has to make both inequalities true. So this would be an example of a no. Right, because only one of the inequalities is true when we replace x and y with negative 2 and 0. Alright, try these examples down here. Right. And you guys can try these on your own if you want. Right, stop the video and try them, but we'll do these too. Alright, remember, x value, y value in the ordered pair. So for the first inequality, we have 5 is less than 5, right? I already know that's a no. So I don't even have to continue, because if one of the inequalities is a no when we replace the ordered pair with x and y, then the system is a no. All right, let's try the next system. For the first inequality, we get 4 is greater than or equal to 3 times 1 plus 1. Is 4 greater than or equal to 3 plus 1? The answer to that is yes. When we try the second inequality, is 4 greater than 1 minus 1? Is 4 greater than 0? The answer to that is yes. All right, so because we have two yeses, right, that system will be a yes. Let's try this last example. Right, we're going to replace x with 0, y with negative 5 over 2. Right, so we have negative 5 over 2 is greater than 1/2 of 0 minus 8. Is negative 5 over 2 greater than negative 8? The answer to that is yes. Try the second inequality. Is negative 5 over 2 less than 6 minus 0? Is negative 5 over 2 less than 6? The answer to that is, yes. Yes. So this would also be a yes, because this ordered pair makes both inequalities true. All right, so what's it look like when we want to solve a system of linear inequalities using this graphing method? All right. Well, first we have to graph each inequality in the same coordinate plane. Then we find the intersection of the half planes that are solutions of the inequality. The intersection is the graph of the system. All right. The solution is the set of ordered pairs in the purple region. All right, where the shading is overlapping. All right, we see this purple area in here. That's where the shading overlaps. Right, and where the shading overlaps will be our solutions. All right, so let's try our first example. So first we're going to graph y is less than or equal to 3. So we know that that's going to start at positive 3 on the y-axis. And we know that's going to be a solid horizontal line through that point. And y is greater than that, so we're going to shade right above that. Then we look at our second example. Y is greater than a number x plus 2. Right, that's going to start at positive 2 on the y-axis. And then our slope is 1, so it's going to go up 1 over 1, up 1 over 1, up 1 over 1. We have a dashed boundary line there. Dashed boundary line. Just going to extend that a bit. Extend that a bit. And we're shading where? We are shading above that line because it's greater than. Oops. So I made a mistake with that first one. I see that now. Right, because y has to be less than 3. So my shading for the first inequality should be below that. I want to do that in blue, right, because y is less than 3, so I should have shaded down here. And then we have y is greater than a number x plus 2, so greater than would be up here. All right, now we'll notice, and I'm going to highlight some of this if I can. All right, I won't do this for every example, but at least for the first example, all right, we see that this area in here is where the shading overlaps. All right, right in here. Right, all of that in here, right, which goes on forever, by the way, right, so that goes on forever this way, this goes on forever that way, right. All of these values in here, right, those are your solutions, you know, because that's where the shading overlaps. So these are, well, I'll do that in black. These are the solutions. Black. Solutions. Solutions are where the shading overlaps. So we would have up here would be non-solutions. Up here would just be solutions, all right, for one inequality. And then we have down here, right, where there's just one type of shading, is solution for another inequality, where we're looking for the shading that overlaps. Right, they are the solutions. Now, if you want to check, you pick an ordered pair. So let's pick, I don't know, what's this here? I'll pick this ordered pair. That's at negative 1, 2, 3, negative 4, comma 0. Let's check it. Right, see if that works. So negative 4, comma 0. Is 0 less than or equal to 3? Yes, it is. Is 0 greater than negative 4 plus 2? Is 0 greater than negative 2? Yes, it is. Right, so that ordered pair, negative 4 comma 0, represents just one possible solution in that shaded area. Okay, let's look at our next example. We have y is greater than or equal to negative 1. Start down here at negative 1. And we know we're going to have a solid line through negative 1. Right, so we have our solid line through negative 1. And straighten that out a bit. Right, we have a solid line through negative 1. And we're shading above that, right, because y is greater than or equal to, right? So we're shading above that. All right. And then we have our second equation, going to be start at positive 2. Start up here at positive 2. And we're going to be going down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1, down 1 over 1. And then we have a dashed line. Got my dashed line ready. All right, I'm going to go with my dashed line there. Right, so our boundary line is dashed. We are less than that, so I'm going to shade below that. Right, and I am looking for the overlapping shading where I see blue and where I see orange. And that's going to be this area in here. So I'm going to pick a point in that shaded area, right? And I see 0, 0 is in that area. So 0, 0 should be a solution. So when I check, first inequality is 0. Is 0 greater than or equal to -1? Yes. When I check with the second inequality, is 0 less than 0 plus 2? The answer is yes. So I see my solutions are in here. Right? That's where my solutions are, the overlapping area. Right? Next example. We have to rewrite these inequalities in slope-intercept form. So this is going to be what? The first inequality is going to be y is less than -2x minus 1. The second inequality is going to be y is greater than -2x plus 3. Right, so my first inequality, start down here at -1. I'm going to go, what, down 2 over 1 from my boundary line. Down 2 over 1, down 2 over 1. We have a dashed boundary line. So I'm going to draw that dashed boundary line, extend it. Right, that should be good. My second inequality is going to start at +3. That's up here. And we're going to go down 2 over 1. Right, so we see lines with the same slope, different y-intercept. Right, we have dashed boundary line here. Same slope, different y-intercept. So we know that the lines are going to be parallel. Right, but let's shade. Right, the first inequality, y was less than -2x minus 1. We were less than that, so that should have been all of this stuff here I should have shaded. And then here we have y is greater than -2x plus 3. Right, we see that we have no overlapping area. Right, so that would be an example of no solutions. Right, there are no solutions because there is no area that overlaps, with the half planes. All right, getting a little neater with this line. Right, details, let's fix that. There we go. Next example. All right, let's rewrite in slope-intercept form. The first one's going to be what? What's going to be? Y is going to be greater than, nope, let's show the work here because this one's tricky here. We have a negative coefficient for y, so we're going to have to reverse the inequalities. So first we're going to subtract x. Subtract x. So I have the opposite of y. It's going to be greater than -x plus 2. Right? Then we're going to have to divide by -1. Divide by -1. So we get y is less than. We've got to reverse the inequality. Negative divided by negative is positive 1x minus 2. Then I get my second equation. Okay, I'll do that one in blue. Right, start by subtracting x. Subtracting x. So that's going to give us the opposite of y is less than or equal to -x minus 3. When we divide both sides by -1, right, we get y is greater than or equal to. Once again, we have to reverse the inequality. It's divided by a negative number. Negative divided by negative is positive 1x. It's going to be plus 3. Right, let's check this out. So the first inequality, we're going to start down here at -2. And I'm going to go up 1 over 1. 1 over 1. Up 1 over 1. We have a dashed boundary line. I'll go up here. Extend that line. Looks good. The second inequality, do that in blue, using my Nick colors as always. Right, y is greater than or equal to a number x plus 3. And so that's going to be what? Up here, 1, 2, 1, 2, 3. It's going to be up here at positive 3. And we're going to do what? Up 1 over 1. Up 1 over 1. Up 1 over 1. Up 1 over 1. right, I'm going to have a dash boundary line. Oops. Dash boundary line. I didn't do my shading, so let's do my shading here. I should have had y is less than a number x minus 2, so that's down here. My other boundary line, y is greater than number x plus 3. Right, so it looks like we have no overlapping area. So because we have no overlapping area, this would be an example of no solutions. Right, there are no solutions there. Right, we have our next few examples. Right, let's take a look at each one of these, and we want to identify a solution if it is possible. All right, so we start with the first one. It's in slope-intercept form. So we graph start at positive 4. 1, 2, 3, 4. And we're going to be going down 1 over 1. Down 1 over 1, down 1 over 1, down 1 over 1. We have a solid boundary line here. So I draw my solid boundary line. Right, that looks good. My second inequality, we're shading in which direction? We're above that. So I'll shade above that. And then here, next one. It's in standard form. But when we put that in slope-intercept form, we're going to have y is less than or equal to the opposite of x. So that would be a y-intercept of 0. Down 1 over 1, down 1 over 1, down 1 over 1. That's going to be a solid boundary line. And it looks like we'd have, let's say, less than or equal to when we shade, and have no solution there. Right, no solution. Our next example, let's see what we have here. The first inequality, we're going to start down at -3. And from -3 up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. We have a dashed boundary line here. Just going to extend that line. Extend it. That should be good. And where are we shading? We are shading above that. So we're going to shade over here on that side of our boundary line. Next inequality, we start at positive 1. From positive 1, we're going to go down, no, up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. We're going to have a solid boundary line here. Right, solid boundary line. Let's just extend that a bit. And we're shading what direction? Above that. So we're shading up here in blue. Right, where's the overlapping area? Right, the overlapping area is in here. So the solutions are here. Well, those are the solutions. All right, and let's check an ordered pair from here. So I'm going to check, let's do this one here. That's it, 1, 2. So is 2 greater than, right, applying 1, 2, I'm checking. So is 2 greater than 2 times 1 minus 3? Is 2 greater than -1? That checks. Let's try the next one. Is 2 greater than or equal to 1/2 times 1 plus 1? Is 2 greater than or equal to 1.5, right? So that checks as well. All right, and our last example here, we're going to have to put in a slope-intercept form. So the first inequality is going to be when we add 2x, add 2x. We're going to have y is less than 2x plus 4. And then the second one, we're going to have y is greater than -2x plus 4. So the first inequality, we're starting at plus 4. 1, 2, 3, 4. We're going up 2 over 1. We have a dashed We have a dashed boundary line, so dashed boundary line here. We're going to shade which way below that. So I'm shading below that boundary line. That's going to be down here. And then the next one, we are at positive 4 again. From positive 4, we're going down 2 over 1, down 2 over 1, down 2 over 1. We have a dashed boundary line, dashing that line, and I'm going to extend that line here, extend it, and we're shading which side of the line? We are above that, so above that's going to be here. We're looking for the overlapping shading, so that's here are my solutions. All right, that's where the shading overlaps, so I'm going to pick a point. We'll try this point here that looks like 1, 2, 3, 4, comma 1. We'll try that. 4, comma 1, we'll test. Testing the original inequality. So is negative 2 times 4 plus 1 less than 4? Right, let's say that's negative 8 plus 1. Is that less than 4? That checks. Try the second inequality. 2 times 4 plus 1. Is that greater than 4? Is 8 plus 1 greater than 4? And that checks as well. So that solution area where it overlaps, that looks like the solutions are. Okay, finally we want to be able to write a system of linear inequalities, and to do that we just need to be able to write the equation for the boundary line, and then see if the line is solid or dashed, and what side of the shading we're looking at here. So let's start with the dashed line first. So I'm going to do this one, this dashed line, the orange line. Alright, we see that the y-intercept is here. The y-intercept here is what, at 2. So that means b is going to be equal to 2 for slope. Slope looks like it's up 1 over 1, up 1 over 1, up 1 over 1 from that point. So slope is 1. We have a dashed boundary line, and we're shaded below that. So y has to be less than, we have x plus 2. Let's take a look at the other line. Do that in blue, right, or actually red, so it stands out. Right, so if I look at that red line there, we see that it's a horizontal line, so the slope is 0. The y-intercept is down here at negative 2. Right, so we have b equals negative 2, n equals 0. We are shaded above that, and it's a solid boundary line. So y has to be greater than or equal to negative 2. So that's the system. That's our first example. Let's look at the next example. Okay, once again, you want to find the slope. You want to find the y-intercept. Alright. So let's say, and then to the pin the accent down here. Okay, and we'll start with the solid line first, down in red. Looks like we have a vertical line, so this where the x-intercept is at 3. Right, we know that our m is undefined. Right, undefined. So we'd have a line where x is going to be equal to 3 is the boundary line, but we are to the left of that, so x has to be less than 3 would be the first, or less than or equal to, because it's solid. There we go. So x is less than or equal to 3 would be the first inequality. Let's look at the dashed boundary line one. That's this one here. In that orange. So we have what here? n equals, what do we have? Y-intercept b equals b is negative 1. Slope here is up 2 over 3. Up 2 over 3. So n equals 2/3. We are shaded above that. So y has to be greater than 2/3 x and minus 1. So that's the system we're looking at. So we have a few more examples on this page. I don't know if we'll do all of them, but we'll do these last two. All right, so we're running long here. Start with the horizontal line. That's this line here. For the horizontal line, you know that the slope is 0. You know that our b is equal to, what's that? Here, positive 2. So, and we are shaded below that. So we have y is going to be less than or equal to, because it's solid, 2. Then we look at our dash line. Dash line's here. Right, the dash line, see a y-intercept here of 1. So b equals 1. The slope is down 1 over 1, down 1 over 1, down 1 over 1. M equals negative 1. It's a dash boundary line, and we're shaded above. So y has to be greater than negative x plus 1. There's our system. Right, I think the last one we'll do. We have two solid lines. First one, I'll do in red. Y-intercept is down here at negative 2. So b equals negative 2. Our slope looks like it goes up 1 over 2, up 1 over 2, up 1 over 2. So n equals 1/2. We are shaded above that. So y is greater than or equal to 1/2 x minus 2. The other line, we have a vertical line, slope's undefined. The x-intercept here is at 1, and we are shaded to the right of that, and it's a solid line. So x is greater than or equal to 1. There's our system. All right, you guys can try these 3 examples down here if you'd like. All right, the solutions are done in our notes. Hopefully that's been helpful for you guys. Take care.